Uh, Very good evening to one and all. Hope all of you are doing well and you are safe at your home. Today we are going to discuss a new topic, which is gas welding. So in this topic we are going to discuss about the flame characteristics, the welding equipment used, and the fluxes. We will also discuss about the fluxes, and we also discuss about the filler rods, and we also come across different types of gas welding. Let's move on to the topic directly. Yes, let's see. What do you mean by a gas welding? So this gas welding, it's a fusion welding process, and as the name implies, I mean the fusion welding process. In this fusion welding process, the heat is derived from combination of a fuel gas and an oxygen mixture, which means there is a combination of fuel gas and oxygen mixture. Now, which means the fuel gases such as acetylene, propane, hydrogen, and natural gas are used along with oxygen. That's why I told you combination of a fuel gas and an oxygen mixture. So among the different gases I discussed, like acetylene, propane, hydrogen, and natural gas, among these fuel gases, the acetylene is the most popular, and when the acetylene is used in combination with oxygen, the welding process is called oxyacetylene welding. And here in this welding process, I mean the oxyacetylene welding process, when we are discussing about the gas welding, the first welding process which is very commonly used is oxyacetylene welding. And the maximum temperature developed by oxyacetylene welding flame is 3200 degrees Celsius. And please note that you are not supposed, or you do not require any external forces to be applied for the welded joint to be joined. So that's why it's called a fusion welding process. So what is happening in this welding is the edges of the joint are melted by the heat and fused together to obtain the joint. Sometimes a suitable filler is also added. Now let's look into the flame characteristics of an oxyacetylene welding. So here in this oxyacetylene welding, the flame is the most important tool. So you know well that certain amount of oxygen is very much required for the combustion to take place. So when the supply of oxygen varies, appearance and characteristics of flame is also varies, which means depending upon the quantity of oxygen along with acetylene, the characteristics of flame varies. So based on the ratio of oxygen and acetylene in the gas mixture, let's see three different type of flames. One is a neutral flame, and the other one is an oxidizing flame, and another one is a carburizing flame. So let's see one by one. What is a neutral flame? Which means here for the combustion, approximately equal quantity of oxygen and acetylene are mixed in the welding torch and burned at the torch tip. So when you hear about, so we are going to discuss about three different flames in an oxyacetylene welding depending upon the constitutive ratio between the oxygen and acetylene. So in the case of neutral flame, you use equal quantity of oxygen and acetylene. They are mixed in the welding torch and burned at the torch tip. So in this process, the maximum temperature can be generated is up to 3200 degrees Celsius. Okay. So the neutral flame has a small light blue inner core near to the torch tip. Please have a look at the schematic diagram which is shown here, right side. You can see that the neutral flame, which has a small light blue inner cone, this is the inner cone near to the torch tip, and an outer envelope, this is the outer envelope, which is dark blue in color, surrounding the inner cone. There is an inner cone, there is an outer cone, the inner cone which is in light blue and the outer cone which is in dark blue. Okay. So in this neutral flame, the acetylene is completely burnt, and this is the most desirable flame in oxyacetylene welding. When you are going to use this oxyacetylene welding, the neutral flame is preferably used. So this neutral flame is preferred for welding mild steel, stainless steel, cast iron, copper, and aluminum. Okay. So this is actually an actual image which is taken during the welding process. You can see an inner core and outer core as we said. Let's look into the another interesting oxidizing flame. What would be the oxidizing flame? If neutral flame is equal ratio of oxygen and acetylene is used, then what would be? Yes, of course, as you um, think of, the oxygen is supplied in excess of acetylene. So when oxygen is supplied in excess of acetylene, the flame is called oxidizing flame. Now the appearance is similar to the neutral flame which we have seen just before. We have a small inner core and an outer core, and a smaller inner core of dark blue color. This is actually dark blue, and we have an outer um, core, and you can see that this inner cone, the inner cone which is dark blue in color and which is more pointed than which is appeared in the neutral flame, and the outer flame envelope is much shorter and is not sharper like a neutral flame. Look at this. Okay, you can see then outer blue flame and inner cone which is dark blue in color. And how much temperature this flame can generate? Little bit higher than the neutral flame. You can generate a maximum temperature up to 3300 degrees Celsius. And this excess amount of oxygen sometimes causes oxidation of the weld metal, and as a result it is not used to weld steel. It is not used to weld steel. But a flame having slightly oxidizing nature is used to weld copper based metals, zinc based metals, manganese steels, and cast iron. So in these cases, as I told you, we have a small um, oxidizing presence of um, small oxidizing flame is there. So because of this oxide film present, which acts as a protective cover over the weld metal. So the presence of excess oxygen which acts as a protective cover over the weld metal in welding of zinc and copper based alloys. And another important flame is a carburizing flame, and in this case the volume of oxygen can be reduced and the mixture will become rich in acetylene, and as a result we will get a flame which will be the resulting flame will be carburizing or reducing in nature. So similar to the neutral flame, it is similar to the neutral flame but with an additional intermediate reddish flame. Look at the diagram. In between the inner cone and the outer envelope, you can see in the, nicely shown it over here. You have an additional intermediate reddish flame between the inner cone and the outer cone. You have an outer blue cone, you have an inner white cone, and an intermediate red cone. You can see it. But this flame is not suggested for general use, and as we discussed in the case of last two flames, here also you can generate a temperature up to 3000 degrees Celsius, and the advantage is it ensures the absence of oxidizing condition, and it's suitable for welding high carbon steel, cast iron, and copper-based alloys. So these are the three different types of flames which can be generated using in an acetylene welding: neutral flame, oxidizing flame, and cauterizing flame. Now let's familiar with the welding equipment. So let's familiar with welding equipment used in a oxyacetylene welding. Let's look into the main parts. Look at the diagram. You can see an oxygen cylinder. You can see an acetylene cylinder. You can see some connecting hoses. You can see which connects the welding torch with the cylinders. And you can see. You can again see. So these are the main parts: the cylinder, the cylinders, hoses, and the torch. What is an oxygen gas cylinder? So this is an oxygen gas cylinder. Okay, and it is a solid cylinder made up of mild steel or an alloy steel. Usually this oxygen gas cylinder is generally painted in black color. Usually the oxygen gas cylinders are painted in oxyacetylene welding. The oxygen cylinders are painted in black color. And please note that the cylinder needs to be always kept upright. You should keep the cylinder upright always. And you can, as in the figure, you can see that the cylinder is provided with a pressure regulator. So, and the oxygen is stored at high pressure inside the cylinder, and the pressure regulator which helps in supplying the oxygen at regulated pressure for the welding purpose. Now, what is an acetylene gas cylinder? This is also a solid steel cylinder, and it is painted in maroon color, and it is also kept upright always. This is actually due to safety reasons. So in addition, there are several safety measures provided in the cylinder, the acetylene cylinder. The gas is kept at high pressure inside the cylinder, and you can also see a pressure regulator here, and this pressure regulator, used to reduce the pressure and regulate the supply of acetylene gas for the welding. Yes, it regulates the acetylene gas for the welding. Now you can see a connecting hoses, and you can please note that for the the hose which carries oxygen gas always colored in blue color, and acetylene gas which is always colored in red hose. You will use a red hose for oxygen carrying acetylene gas, and for oxygen gas you will always use a hose having red color. Okay, usually rubber hoses are reinforced with some material called canvas are preferred for this purpose. Now the welding torch. Yes, the welding torch, which forms a very important part in an oxy-acetylene welding. You know that from the pressure regulators on the cylinders, the gases are carried to the welding torch through the hoses. We discussed about it. Now the pressure regulators supply the gases at reduced pressures, and the welding torch. Inside the welding torch, the mixing takes place. The oxygen and acetylene, and it controls the flow of gases to the welding nozzle. So the welding torch which mixes these two gases, and it also controls the flow of gases to the welding nozzle. So as the gas mixture comes out of the torch tip, it is ignited to produce a flame for the welding process. So you can see a high pressure welding torch is used for this purpose, for welding. And you can see that the welding pipe is also known as the blowpipe. So the welding torch used here is also known as blowpipe. And here, as I told you, oxygen and acetylene are fed to the torch at equal pressures and are mixed prior to being fed to the nozzle tip. Now the welding nozzle, which enables the welder to gauge the flame and direct it towards the welding spot easily. This is a very important part in an oxyacetylene welding. Now let's see. Let's familiar with the gas welding technique. Using this gas welding, joints like butt joint, lap joint, T-joint, and the corner joints you can make. Both fillet and groove welds can be used depending upon the workpiece and the strength requirements. And again, you please note that the edges of the workpiece needs to be made needs to be made free from rust, grease, or oil prior to welding. That's very important. If you are going to do a gas welding, please ensure that the part to be welded needs to be made free from rust, grease, or oil. And there are two techniques of welding followed in gas welding. One is forehand and backhand welding, based on the position of welding torch and the filler rod. Let's see what is meant by a forehand. It's also known as left ward technique. So in this technique, you can see that the welder who holds the welding torch in the right hand and the filler rod in the left hand. So the welding begins in the right hand end of the joint and proceeds towards the left hand side. Okay, so that's called a forehand or left ward technique. So please note that the welding flame is directed away from the finished weld. Welding flame is away from the finish. This is the finished weld part, and this welding flame is away from the finished weld. Used for metals having thickness less than 5 mm, and for thicker workpieces, V joints are used. So this is a forehand or leftward technique. Another technique is backhand or rightward technique. Of course, as you think, the welder holds the welding torch in the right hand and the filler rod in the left hand. Same. But the welding begins in the left hand side end of the joint and proceeds towards the right hand side. You can see that in the last case, the welding begins in the right hand end and proceeds towards the left hand side. Here opposite. The welding begins in the left hand end of the joint and proceeds towards the right hand side. You can easily see, if you look at the diagram, you can see the difference. Okay. So the welding flame is directed towards the finished weld, and the filler rod between the torch and the welded region. This is a welded region. Okay. You can see the welded region. The welding finished where the filler rod. This is between the welding torch and the welded region. So in the last case, the welding flame was directed away from the finished weld, whereas in this case, the welding flame is directed towards the finished weld. Now let's look into the filler metal. So what do you mean by a filler metal? Some additional material is usually added to the weld pool to help filling the weld joint. Okay, sometimes the filler metal is very much required. So it is made up of some metal or some compatible metals, the same metal, same base metal as this base metal. What is a base metal? Usually this filler metal is usually made up of the combination of the same base metal or the compatible metals with base metal. So it is available in the form of small rods, which is called filler rods. You can see some of the nice aluminum filler rods and copper filler rods are shown below. The filler rods are available in various sizes ranging from 1.5 millimeter to 6.3 millimeter dia, and actually this is selected based on the thickness of the base metal. Another important concept we are going to discuss with the oxy and gas welding is the fluxes. Actually, why the flux is used? Material used to prevent the and prevent the oxidation of metal surfaces. So this is a material used to prevent or retard the oxidation of metal surfaces. The flux is a fusible material and it generates gaseous shield around the weld zone. what is happening here is the flux that forms reacts with the oxides and a slag is formed, and the slag which floats above the molten metal pool. The, from the from in market you can buy the flux in powder form, paste form, or liquid form. The flux is available in these three different forms: powder, paste, or liquid form. See, please note that no fluxes are used while welding steel. For welding stainless steel, cast iron, aluminum, copper, and their alloys, suitable fluxes are used. Then what constitutes a flux? Some of the commonly used ingredients of fluxes are borax, boric acid, lime magnesium silicate, sodium chloride, potassium chloride, etc. So a combination of these constituents are generally used as ingredients for the fluxes. Now let's see what are the advantages, disadvantages, and applications. The advantages are the welder can control the temperature of the metal at the weld zone. If you are going to use a flux, welding equipment is, the advantages of, yeah, the advantages of a gas welding. The welding equipment is low cost, is versatile, and generally portable. And the maintenance cost of the equipment is comparatively low with other welding process. Disadvantages include you cannot use it for heavy sections, and refractory metals and reactive metals cannot be welded using this technique because we are using some kind of gases to generate the flame, so it's not recommended. May cause health hazards. What does it mean? Which means this flux produces fumes which are irritating to you, to human eyes, nose, throat, and lungs. So the health hazard aspect is little bit not good for the oxyacetylene welding. What are the applications? It is used for joining thin materials, joining most ferrous and non-ferrous materials. Automobile and aircraft industry is widely used. Sheet metal fabrication work, this type of welding is used. Repair and maintenance work, the gas welding is used. And let's familiar with some of the few important techniques in gas welding. Now we are familiar with the oxyacetylene welding. Now let's see what do you mean by oxyhydrogen welding. It uses gases like hydrogen, propane, butane, and natural gas in combination with the oxygen. It's called oxygen hydrogen welding. What is the maximum temperature you can generate? So the maximum temperature from oxyhydrogen and oxypropane flames is around 2500 degrees Celsius, which is less than oxyacetylene welding, and it is used to weld metals of low melting point, metals like aluminum, magnesium, lead, and their alloys. And the flame is not visible, and there are no combustion zones as in oxyacetylene flame. നേരത്തെ oxyacetylene flame you have see an inner cone and outer cone, intermediate zone. So as the flame is not visible, you will not be able to identify the combustion zones as in oxyacetylene flame, and it is difficult to obtain a neutral flame in the case of oxyhydrogen welding, and then no carburizing flame. So special type of regulator, you need a special type of regulator to use to control rate of hydrogen supply. And what is air acetylene welding? Another type of gas welding. So the gas flame obtained from the combustion of acetylene with atmospheric air. That's a combination of acetylene with atmospheric air. Here you are not using a filler material, or you are not applying any external pressure. It uses a flame having low temperature compared to any other fossil fuel gas process. Uses a flame having low temperature. And what are the applications? Used for soft soldering of copper pipes, silver brazing of parts of refrigeration equipment, welding of light sections. You use this type of welding. And pressure gas welding is another type of gas welding process, which means using this welding process, here the interface between the base metal pieces is heated by means of an oxyacetylene torch, and after the interface begins to melt, the welding torch is withdrawn and the external pressure is applied to keep the two metals of metal pressed together till the interface gets solidified. അപ്പോൾ ഇവിടെ നമ്മൾ ഫ്ലെയിം കൊടുക്കുന്നത് കൂടെ external pressure would apply. That's the reason why it is called pressure gas welding. After interface begins to melt, welding torch is withdrawn and external pressure is applied. So this is to keep the two pieces of metal pressed together till the interface gets solidified. And here, commonly, usually the pieces of metal are arranged as a butt joint and small flash will be formed during solidification. So we learned about the oxy-acetylene welding, oxy-hydrogen welding, air acetylene welding, and pressure gas welding. That's all about it. Thank you.